Hello everybody, today we'll be going over a volumes and geometry problem at the IB Math Studies level. And so the problem gives us that we have a type of candy that is packaged in a right circular cone that has a volume of 100 centimeters cubed and a vertical height of 8 centimeters. The vertical height is shown right here and it's the dotted line, okay? The fact that it's a right circular cone means that it is that this height is perfectly straight up, and if it's perfectly straight up, that means that there is a right angle right here. And if there is a right angle right here, that means that there is a right triangle right here. And there is also a right triangle going in this direction and also in that direction, okay? If you get creative with how you look at it, okay? And so that is what the value of it being a right circular cone is. But for part A, we're going to find the radius r of the circular base of the cone. And so, since we're dealing with cones, we open up our trusty rusty formula booklet and look at anything and everything that has to do with cones. And between these, we will find that the volume of a cone is going to be equal to a third times pi times r squared times height. So looking at this, we know that we have our volume because it is right here. We know that we have our h because it is right here. And we're only missing our r, which is exactly what we are trying to find. And so we plug in all our values here. 100 for volume being equal to a third times pi times r squared times h. Now, of course, we want to get r alone. So first I will multiply 3 to both sides in order to get rid of this guy here. So I end up with 300 is equal to pi r squared times h. I will divide by 8 both sides and end up with 37.5 equal to pi r squared. Divide both sides by pi. And I end up with r being equal to 11.9366. Now I proceed to do the square roots of to both sides. That way I get rid of the squared up here. I end up with, oops, and I end up with r being equal to just about 3.45. Now we make sure to not forget our units, which is in centimeters. So that is how you do part A. Moving on to part B, we're going to find the slant height L of the cone. And so remember how we said that there is a right triangle right here? Well, that means that, a right angle. That means that there is a right triangle way over here. And so if I pull out that right triangle, it's going to look like this, right? And so I have my 8 over here. I have my radius on top, which we now know is 3.45. And we are missing the slant height L. So here, anytime you have a right triangle, you need to think of Pythagoras theorem. So I know that I can apply the a squared plus b squared equals c squared, okay? The only thing that matters is that my c squared is the one that is alone, which is like the long side, okay? The longer side has to be c squared. And so I will have 8 squared plus 3.45 squared being equal to L squared. So my left side turns into 75.9025 being equal to L squared. So now I have to square root both sides, right, to get rid of this guy. And I end up with L being equal to 8.71. And so that is how you do part B for the slant height L of the cone. Finally, we're going to find the curved surface area of the cone. And so again, we open up our formula booklet and we see what can we do or what can we use to find the curved surface area of the cone. Here we will discover that the formula for the area of the curved surface area of the cone is pi times r times L. And so we know we have r from part A, and we know we have our L from part B. And so we plug everything in. We're going to have pi times r, which is 3.45, times L, which is 8.71, And we end up with our area, the curved surface area of the cone being equal to 94.6 centimeters squared. Okay, now notice that this is the area of just the curved part of the cone. So this means that this area here is what's 94.6 centimeters squared. If the problem were asking for the whole surface area of the whole problem, I would also need to find the the surface area of the circle that is up here. But since it's not asking for that and it's only asking for what I drew in black, that is how you do part C. All right. And always at the end of your problems, make sure that you put units in all of your answers. Here I am missing units for part B. So if you notice that, good job. But anyway, that is how you do this problem. I think the most important part, as per always, is that you check your formula booklet and see what tools you can use. At the end of the day, more than getting familiar with it, know that you can always bounce back to it, and there will probably be one or two formulas that will come in handy for every single problem. So, with that being said, that is how you solve this problem. I hope it helped.